So before we really get into our four input K-map example, one of the first things I want to talk about is a more express way to label our K-maps and our and consequently how we label our truth tables, just to make things a little bit more easy. So we know that each one of our rows has a number that corresponds with it, and that's just the decimal equivalent of this binary number, right? So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So we've got these labels, and now let's look at our K-map. So if this is a 4 input, we're going to have a kind of a 4x4 grid here. Make sure I draw this nicely. I'm going to cut this into 4 columns and 4 rows. Now, we have, right, we've always got our little line here that splits up our axes, and we've got our most significant letter, A, then B, then C, then D. And kind of a general way to put this is each one of these cells corresponds to one of these rows, and we can actually kind of memorize this order or know how to find it if we look at our binary numbers here. So remember, we're counting in gray code: 0, 0, 0, 1, 1, 1, 1, 0. And it goes the same way down this axis as well. So we know that we can play this game where we find the cell where A, B, C, and D are all zeros, which happen to be right here. And so we know that this is our cell 0. And then we can look for A is 0, B is 0, C is 0, D is 1. So that's 0, 0, 0, 1. And oops, and that's row number 1 in our truth table. And now, here's where things kind of get a little unexpected, but it's just kind of because of the way we label things. If we look for 0, 0, 1, 0, we see 0, 0, then 1, 0 is down here. So this is cell 2. And now I'm just going to kind of go through and label the rest of these. This is kind of a good exercise that you might want to consider doing for yourself when working out. But turns out that this is 3, 4, 5, 6, 7, and then once again, because of how we label things, it's going to bounce over to here, and we're going to have 8, 9, 10, 11, 12, 13, 14, and 15. So that's what rows in our truth table correspond to which cells in the K-map. So normally I drew them big here, but kind of a good thing to do is to draw them small in the corner here when you start out. So 0, 1, 2, 3, 4, 5. So what this does is it leaves the rest of the K-map available for you to fill it out. Right, we want to be able to put our big 1s and 0s in there. So this is kind of fully labeling the K-map So we can work a little bit easier here. It's a little bit extra work, but it just makes the whole process easier. So let's go ahead and finish this problem here. So let's say uh, we've got 4 is a 1, 5 is a 1. What else do we got? 12 is a 1, 13 is a 1, 14 is a 1, 15 is 1. And we're going to assume that the rest of them are all zeros. So let's fill this out here. So it's a little bit easier, right? Because we can just say, all right, where's cell 4 now? Oh, it's right there. So that's a 1. Cell 5 is a 1. Cell 12 is a 1. 13 is a 1. 14 is a 1. And 15. And there we go. It's a little bit easier, especially if you can remember this order exactly. This 0, 1, 2, 3, 4, 5, so on and so forth. The biggest thing is don't forget that our numbering starts at 0 and not 1. I admit that I've made that mistake multiple times, and I start out and realize that I end up with 16 there, which is not correct. Now let's circle our implicants and make sure that we're finding prime implicants. So let's go with a nice purple here. So I could circle this one. That would be an implicant, but it wouldn't be a prime implicant, because I always like to think of these things as kind of like growing, I guess, a morbid example right now is like a growing plague, right? It just kind of wants to spread out as far as it can get. And so here, since these ones aren't social distancing, this is actually going to spread out across all of them, which in our case is good. We want to have the biggest implicants ever possible. So here is one implicant, and it can't get any bigger without being like weirdly shaped. So we know this is a prime implicant. We can't determine if it's an essential prime implicant until we have a full cover, until we've got everything covered. And that's because our distinguished one cells, we can't determine our distinguished one cells until we've got all of our ones circled, because we need to know where intersections are at. And so we could circle these ones, but we got to remember that it's okay to have overlap, meaning I can circle all 4 of these, and that makes a bigger implicant. And now what we can do is say, where are my distinguished one cells at? And so we see, we want to look for the ones that there's no overlap. So like this is not a distinguished one cell because it's covered by 2 implicants. Same with this one. So that turns out to be this one, this one, this one, and this one. So that means we have 2 essential prime implicants, and we also have a cover, right? All of our ones are covered. So now the last step we can do is write our expression. So this first implicant here, let's go with a different color, let's go with green. This first implicant here, what stays constant? Well, A changes from a 0 to a 1, but B stays as a constant 1. So we're going to put B here. And then let's look at these 2 rows here. C stays as a constant 0. So since it's a 0, we use C prime or C naught. And D changes. So looks like B C naught is this term. And now let's look at this implicant. Looks like A stays the same as a 1. B also stays the same as a 1. And now let's look at C is a 0 for these 2, but it's a 1 here, so C changes. And D changes from a 0 to a 1. So the moment we see just one change, we know that it's not in this function. So that means, in this case, x equals... remember, the way that you list these terms doesn't really matter. I usually try and go the smallest term to the biggest term, meaning like the smallest amount of variables to the biggest, but it doesn't really matter. Especially in this case, they both have 2 variables. So we OR them together. And there we go. There's our final function for this 4 input K-map.